What's the countdown time?
I don't know, but I turned on the YouTube Live.
Okay.
Mm-hmm. 4 minutes until we're ostensibly starting with.
All right.
To some degree, let him suffer if we're streaming on YouTube Live and he doesn't want us.
Right.
The platform would be good to go, right?
As I said, I think
I can unmute. The people on the live stream can hear us on the YouTube stream.
Yeah, I got another canned message back from Eric.
Yeah. Looks like other Eric Gunter posted something in the air meet. I assume you can hear us. Maybe. Well, I unmuted us anyway.
Oh, makeup. All right. Well, I'm gonna turn my computer off. This is it. I got my phone on vibrate and sound down to vibrate, so it shouldn't be coming on. I don't even know where in the hell it is. Oops, sorry about that. I am YouTube Live, aren't I?
Yeah, I think we are.
I'll take my drink over there. All right, go ahead. Shoot me on the interwebs. Okay, I'm on the interwebs now.
I don't know, there's 7 people here, but I'm not sure if they can hear us or not.
Okay, we don't know what's going on. Again, we finally managed to get out of the Learn to Solder workshop by redoing our tickets. So we got out of there and we got into this audience, this workshop as an attendee, but the person who can start it can't get in and start it again. I can't start it. I'm an attendee. I'm just the speaker and an attendee, so I can't start it. So we went over to YouTube Live again. We've been waiting for 45 minutes to an hour to get this thing resolved, and we haven't been able to figure out how to do it. And some of you poor saps might still be stuck over in the Learn to Solder workshop, because I think that's still going. That's been going since, 10 minutes of 1 yesterday. Do you know if that's still going or not? I don't know. Anyway,
as far as I can tell, it was still...
as far as we know, it's still going over there, but we're not there. But there might be some other people stuck there. So here we are on YouTube Live again. So we're gonna just start in and see what happens, and
we might give a few more minutes. There's only a couple of people in.
Okay, there's only a couple of people out there supposedly. Anybody want to shoot us a thing back on YouTube Live and say hi?
I see John Craig and Eric Gunter there.
John.
It says
Eric.
7 concurrent viewers, but I only see 3 people there, so I don't know what.
How about D? D, are you there? I shot a video for you early this morning, just for you, but I didn't get a chance to post it.
Recording, so
Okay.
as soon as the air meet.
We are recording this session. Might as well. I'm not going to do it again. So we're just sort of waiting for maybe some more people to congregate over here. We got, on YouTube Live, we got all the time in the world. So we can shoot the breeze. You can ask me questions. Come on, ask me some questions. Hit me with something. See, this is what we've been doing all yesterday morning, sitting here twiddling our thumbs, waiting for someone to start our thing, and it didn't happen until 10 minutes of 1, I think they finally started us.
Yeah.
So by that time, we'd already been on YouTube Live for like 20 minutes. So we kept both feeds going. So just sit here, twiddling our thumbs, waiting for something to happen over there.
Yeah.
Okay. Hit me with a question before I fall asleep. I didn't get much sleep last night. I got home and I was inundated with emails. People trying to find out why the thing didn't go off and where the ticket was, and I got nothing to do with that. I just volunteered to be a speaker.
Yeah.
And that's what I was, a speaker who couldn't get on stage.
No, we're still waiting. Looks like a bunch of other people are still having problems getting to.
Yeah. So we're sorry about that. That's out of our jurisdiction. We're just providing content.
Bruce Barley said he was looking forward to the mini sudden, but that was just a a message. He's not able to get in yet either. Oh, wait, no, he is there. Okay.
Okay, where is he?
Good
Where is he?
audio and video.
Where is he? On YouTube?
Yeah.
Okay,
Yeah.
all right. Glad you could make it.
Terry Griffin is here too.
I can't remember who sent me an email that says early this morning. I got an email. Please do the YouTube again.
Yeah, the quality on YouTube is a lot better.
Yes.
Which people were complaining about that
Yeah.
quality yesterday.
So, the broadcast yesterday. I don't know exactly what the story is, but because it was sort of content that I agreed to do for QSO today. It's up there that anybody can see it, but I'll probably make it a private or unlisted YouTube at some point in time, and then only the people who have bought the boards can get it up on that site. It won't be generic content for anybody. I'm trying to play fair. I don't want to hijack QSO today's event to create something, but then again, we created it in spite of what we had going. So it will be available, and if necessary, we'll shoot it again as totally our content, and we'll keep a video up there. Actually, we have another one. We have the first dry run that we made on Friday.
Yeah.
That's up there as a unlisted YouTube. So maybe we'll put that one up. But did I run through the tools then too?
I don't remember.
I don't remember either. We'd have to go take a look at it. But don't be afraid. We'll have something up there, and it'll be the full boat.
Or maybe we just go back and make ourselves a.
Well, I've always wanted to do a nice YouTube tool thing. So I think I might make one that's just strictly based on tools.
You should, because the sort of best practice there, especially people on YouTube, they used to have a 10-minute limit on videos, because that's about how long most people are watching a video for.
Right. Yeah.
So just do the 10-minute. Do 10 minutes on tools. Then we go back and do. 10
well,
minutes on soldering.
maybe one on soldering irons and suckers and solder, and then another one on pliers.
Yeah.
And screwdrivers.
Because rather than building the whole kit and going through all the parts, you can just focus on the soldering part.
Yeah, yeah.
And then have another one for each kit. Where you can skip through the soldering.
Exactly. So we'll figure it out. I've been working really hard at home. I now have a bench that has a 3-camera OBS studio system on it. I haven't come up to speed on actually being able to monitor and control all 3 of the cameras and the recording while I'm building at the same time.
So have you ordered your stream?
I haven't ordered that thing over there, but my friend Steve, who I've known for 20 some years, he volunteered to be the man behind the curtain, and he's over running he's got, his computer's busy over there, because we got both the YouTube live feed up, and we've got the QSO feed up, and it's busy over there on his monitor. That drive me nuts. So anyway, we will how many people we got on YouTube? Do we know yet?
Hang on a second.
Okay, we got some serious typing going on over there. So I plan on doing lots more shorter YouTubes on stuff. As I mentioned in the feed yesterday, I started building stuff in electronics when I was about 8 or 9 years old. My father was an electronics guy in the Navy, and he always had a bench, and he always did all kinds of repair stuff. And I grew up in Navy housing, and when my father came home from like an overseas, they basically send you overseas, and then they bring you home, and you got sea duty, shore duty, sea duty, shore duty. Whenever he was on shore, I loved my father immensely. In fact, one time, this is a family story, when I was 4 years old, my father had to go on like 3-month sea duty. We were living in Guantanamo Bay, Cuba at the time, and he had to go on and do some sea trials on a ship. And so he took off, and I missed him a lot, to the point where I was biting my arm all the time. And my mother, she tried to stop me with some let's say aggressive punishment, and so I ran away from home, and I was 4 years old, and I ran up the street, and I stayed with a couple up there for several days, and this is inside the Navy base, of course. They were family friends. And I stayed away, and so finally we got everything worked out, and I went back home. I don't know how long I was there, but I was there for more than an overnight or two. Fast forward about, let's see, I must have been 55 or so. Fast forward about 50 years. My father's retired from the Navy. We're living in Maine, and we live right on the ocean. Now, when I say right on the ocean, our front yard was 20 feet, and then there was the rock wall to the beach, and it was a private beach. So all of Father's crazy Navy buddies always would come up and visit because we had a string of lobster traps, and so we had free lobster, and they loved their lobster, and my father would feed it to anybody who came up because it was cheap because we caught it ourselves. Anyway, this guy that I ran away to, his name was I can't remember his name anyway, but he lived in Tennessee. He retired and moved to Tennessee. He and his wife came up. Now, I wasn't living in Maine at the time. I was living in New Hampshire, but that was the husband and wife that I ran away to. So I said, well, I better get home and meet them because I hadn't seen him since I was a child. And so I went up, walked in the house, and there he was. And I swear to God, he was a spitting image of my father. They were both 5'6" Navy guys, with a Navy beer belly, but they could have been twin brothers. So I guess that's why I ran away to that. But anyway, funny story.
So somebody had asked.
Okay, so I'm wandering off topic here, but anyway.
Go over the purpose of the different components on the receiver. And I was looking for a schematic online, but the best I have is the board layout. But
yeah,
can you go over the purpose of the different components of the receiver circuit?
Who's this? Who wants to know that?
Rodney T.
Rodney T. Okay.
T. I don't know. It's just T. The letter T.
Oh, Rodney T.
Yeah.
Well, gee, that wasn't part of the let's build something, but we'll talk about it. I want to say I got a layout here. Okay. This is these are my building notes here. Well, you can't see it from the overhead here.
Upside down there. So.
Okay. All right.
It's down in the corner. Should be down in the corner. You should be able to see it.
Okay. Well, as I say, it's upside down to you, so I'll do this. Okay. How's that? Does that look good? So I mean, obviously resistors, and there's capacitors, and there's some semiconductors and miscellaneous hardware. In the schematic, if you follow the schematic, 9-volt battery comes in, or this is the layout of the board. There is a schematic, I believe, up on my site. I don't have one here.
A little bit over this side.
Over this side?
Yep.
Oh, okay, there we go. Okay. So I'll run through the whole preliminaries by following the circuit. In this case, 9-volt battery comes in and goes through a little header, which is in essence a very cheap switch, very small, compact switch. Then the 9 volts goes over here to a voltage regulator that turns into 6 volts. Primarily because this SA612 is a Gilbert cell mixer chip, and it wants to see a maximum of 6 volts on its supply pin. So a lot of times you either use a dropping resistor from the 9-volt battery to that, or in this case I chose to use a regulator, so I know I got a nice clean 6 volts going to that chip. So you also have the antenna coming in, and it goes into an attenuator potentiometer. In this case, it's either a 1K or a 2K potentiometer, and you can adjust the amount of antenna signal going into the toroid transformer, the antenna transformer, and that's the attenuator is such that if you got a very strong signal, you want to probably knock it down a little bit, because that in essence is a volume control. Okay. There is your volume control because the amplifier is being run at a fixed amplification based on some of the resistors that are surrounding it. Then this attenuation is your volume control. So then it goes into a toroid inductor, which is a isolation transformer, and it's a 4-turn to 10-turn transformer, so to change the impedance of your antenna coming in. and you've got a trimmer cap here, which in parallel with the output coil of the toroid, that forms a in essence a pass filter or a tank filter, tank oscillator, that in essence allows you to peak the whole input at a particular frequency, and you can adjust this, and that's how you tune. Like if you want to get in the 40 meter, and this is a 20 meter design based on the components, so you can actually tweak your input into the Gilbert cell mixer to get the best level of signal in at the frequency of interest that you want. So that's how you tune it. You've got a varactor diode hooked up into the input, the local oscillator of this mixer, and that's got a couple of parts that go around it. You've got an inductor, you've got the 20 meter crystal comes through, goes in as a local oscillator, and that also is slightly changed by this varactor diode and that inductor, the L1 inductor. So you can tweak the local oscillator, which mixes with the antenna, and that's the signal that you get out of the mixer. Now that signal happens to have both an RF and an audio component, but the RF sort of goes who knows where, and what comes out is the difference between the local oscillator and the antenna signal. That's your audio. That goes down to an LM386, which is a amplifier chip, audio amplifier. It's running at basically maximum gain with the 10 microfarad capacitor off the pins 1 and 8. That fixes the gain at 200, I believe. And that output of that oscillator goes through the 220 microfarad cap over to your audio out. And that's big enough to go into a pretty strong signal in the headphones, and it drives small speakers. So that's, we also have the 10K pot over here, which is the tune pot, which is in that whole local oscillator circuit with the crystal and the inductor and the varactor. A varactor diode is in essence an adjustable capacitor. By applying a bias voltage to the varactor, you change its capacitance, and its capacitance changes with voltage. So that capacitor and that inductor and crystal form the local oscillator. So that's how you tune across. I think we can get about 10K using that varactor diode, inductor, and crystal. And then, of course, you can unplug the crystal and put it in a different crystal and tune somewhere else on the 20 meter band. So those are the components. I made some notes on my thing as I went through the pack. To tell the truth, I had sent a couple of these out to get built by other people and comments back, and my number one builder said, no problem. He was a little concerned about this particular capacitor over here in the tuning area. He didn't like how it was positioned, so I changed it slightly on the production boards. But other than that, it was reported it was fine. So I went through the parts yesterday because I've been really, really busy trying to get all these kits out the door. Parts in, kits kitted, and then mailed. And so I went down the list just looking at the parts and the diagram to see mental notes to myself. One of them, the 100K ohm resistor. If you look over here on the layout of the board, it shows a little round circle and another pad next to it with a little line. That particular style of silkscreen notation and the two pads close together is what we call a hairpin mount, which means the resistor stands up and the lead bends over and comes down into the adjacent hole. That's basically a room saving style of mounting on a circuit board. If you ever built a rock mite, you'd find a lot of hairpin turn parts on a rock mite because it's cramming a whole transceiver into an Altoids tin. So that was the first note I had. That was a hairpin. The 1K part marked on the board, attenuator 1K. Well, that can be a 1K or a 2K. It doesn't make it that much difference. Another part located over here in the tune says 10K. And on my earlier data bill of materials, it says 20K. It could be 20K or 10K. I actually bought a lot of 10Ks, so it's a 10K part. That's normally what I put on all sudden storms or sudden receivers. I further went and sorted all the parts and looked at the 56 picofarad capacitors that I got. They were extremely difficult to read, and I can show you that. How many people we got now?
I think there's 20.
20. We've only got 20 lousy people. Well, thank you very much for joining us. But where are all those other people?
I don't know. I posted over in the AirMeet the link to the live stream. So.
All right, I got the bag of parts here, and I'm fishing out that 56. This 56, this is it. Okay, I want to tell you, I've been at this game a long time. I'm 71 years old. I should be wearing trifocals, but I don't. I wear bifocals. That number on that baby, ordinarily I could read most of them, but that is extraordinarily small. And for me to actually verify that that was indeed the resistor, the part in question, I had to use 2 pairs. Yeah, that's a 56 picofarad capacitor. And these are my special Coke bottles that I don't wear because they're Coke bottles. They were made wrong. They work good as a magnifying glass. So yes, that one was hard to read. So you also want to have something in your toolkit. I have this little flat magnifier that's supposed to light up, but I think the battery is dead now. And even with that magnifier, I couldn't read it. So you need 2 magnifiers or one that's better than this. I have another one that's got another level of magnification inside a little inner circle. I normally carry that too, but I don't see it, so I had to resort to the double glasses method. Further down the list, I didn't notice anything other than over here, instead of a 6.8 on my old sheet, I now have 10s, and it's marked simply as L1. Now, this was designed to be 20 meters. You can move it anywhere you want. This circuit works perfectly well at 80 meters all the way up to 10 meters. So if you do want to move it, you have to change the inductor L1, which is why I didn't actually put a value on it. It's L1 based on whatever band of interest you're on. If you're the higher you go in frequency, the smaller the inductor is going to be. So if you're on 40 meters, that probably would be it might be a 6.8. I can't remember. But anyway, I'm going to publish that data later. But if you actually, on my website, there's another kit called the Sudden Storm, which is, is a sudden receiver. Sudden is the name of a village in England. And the guy who designed this circuit initially, way back, was Reverend George Dobbs, a very famous QRPer, lovely fellow. And he gave me permission to do anything I wanted with this. In fact, he designed a circuit for me called the Sudden Storm, which is a simplified version of the sudden receiver that I kitted. I've been kitting that in tuna fish cans for a long time. And if you go look at the Sudden Storm schematic, which is on my website, there's lots of documentation on that. It's almost the same circuit as this, only it's more detailed in the fact that we have band modules on there, and you can instantly swap from 10 meters to 40 meters to 30 meters in a matter of seconds. And what that does is that changes the inductor, that changes this input circuit, and it changes the crystal. So by doing that, you basically can have a multi-band transceiver in a tuna fish can. Fitting it in an Altoids tin, I jettisoned the band module. I jettisoned, lots of other things. Tried to simplify it because I needed all that room to put the battery inside the can. So that's where we're left with. other revisions, rather than give you an 8-pin header that you cut apart, I bought 2-pin headers. So I'm going to actually open this bag of parts now. So the initial design had an 8-pin header that has all the stuff, and now there are 4 2-pin headers. So you don't have to cut them, and they're a little bit nicer, and it's easier for me to kit up. Actually, it's not easier because I got 4 times as many parts there. So I'm going to separate the parts out, which is what you normally do when you build a kit. I'm going to put all the mechanical stuff on this side. There are the headers, and there are the shells that go with them. Here are the terminals that go inside those shells. So here's 2 potentiometers. Here's some resistors up here. I'm going to put an inductor right next to them because it looks like a resistor. Here's some more mechanical stuff. We seem to have gotten this header in there, and we don't use it, so that's a free header. That's a holdover from the other kit. We accidentally, I guess, got too rambunctious, and we kitted an extra part there, but that's all right. Here's the varactor diode. It sort of looks like a transistor that lost one of its legs. We'll put that over there. There's more capacitors. This is just a little 2-pin jumper, shorting jumper like you see in disk drives and stuff to do the addressing and whatnot. That, in combination with one of these headers, is an inexpensive on-off switch. So you put it on, and that activates the battery, and take it out, and the battery is no longer in the circuit, in the crystal. So there are the parts that we have in this. Oh, and of course the IC. So we'll put that over here. So I've lined everything up at the top based on function. I'll get that out of the way. Of course, in the bag also. Now, in some bags, this toroid was in with the parts, and some of them is in the main bag. So I'll put that up there. And we've got the 9-volt battery snap. I'll put that. I'll keep that over in the mechanical side of things. And 2 small coils of magnet wire, green and red. I'll put those over in one corner. So that's all our parts. And of course we had the circuit board. This is a drop-in. This is routed so it drops right into an Altoids tin. Of course, you've got all these pads, and you're going to have leads clipped off on this stuff. So what you do is you take this board and get a thin piece of plastic, a thin piece of cardboard, and you trace it out and you cut it out. So when you drop that into the Altoids tin, then you put the board in. The tin doesn't short out all the stuff. But
did you, on the parts list people got, were the color codes there for the resistors and inductors?
They were not, because this wasn't a learn to get building.
Somebody says their inductor is the same color as their resistors.
The color code's the same, but the body is green. Okay, and it's a little tubbier than the other parts. So that tubbiness automatically tells you that it's different. It's not just a 1% or 2% resistor. It's different, and usually it has a little concaveness to it. The ends are
hold it a little lower, so it's
a little lower.
Yeah.
Okay. Yeah, it's kind of hard.
It's down there, not up.
All right. Okay. The focus is close to the board. So yeah, it's got this hourglass shape, and that's the sure sign that it's a inductor. Yeah. Now, because you have a parts list, you can match up everything and check it off your parts list, and you'll check off the 4 resistors, and then what you're left with is this thing. And of course, the color code is right.
He says his body is not green, but it has the tubbiness. So
yes, it probably is beige,
yep.
A tan.
Same as the resistors.
Same, yeah. But it's a kind of a different. But you see it. It's tubby, and that's because it's a winding of wire inside. Huh?
It resists.
Yeah. In fact, if you try reading the resistance of it, it's going to be pretty much close to a short circuit.
Yeah.
You won't be able to read, much of anything. I don't think. I haven't really done that, but yeah, you have to be comfortable with the part. So that's why you take it apart. You put everything together in their respective groupings, and then if there's anything that you don't understand, like for instance, a lot of people have never seen a varactor diode. Okay, And a varactor diode it looks like a transistor, but only with two legs. It is a diode, but the varactor means it's voltage reacting. And if you put it in a circuit and you hit it with voltage, with a bias voltage, it actually follows a capacitance curve that's very predictable. In this case, I think it from 0 to 9 volts, it changes from, I think it's 60 picofarad down to about 12 or 15. So it has this capacitance range combined with the inductor and the crystal changes the local oscillator frequency. So we'll put that over here again. Now, when you're building a board, if you don't have any board holders or anything like that, you can still build this board. But what you have to do is when you turn the board over to solder parts on, you're going to try to keep the parts all at the same height. So in this case, I would I'd put the resistors in first. I would add the inductor because they all about the same height, so that keeps it kind of even when I'm soldering. Because if it's not even, the board's going to wiggle around when you put some pressure on with your iron, your solder. Then I might add the sockets, and I tried to spread things out so that it tries to stabilize the board. But then again, you need something like a board holder. That's much more convenient. Here's Steve's board holder. Okay, it weighs about, I'm saying that's about 5 or 6 pounds, and you clamp it up in there. And you can see all of a sudden now the board is whoops, wait a minute, you can't see it.
Oh yeah, it's a little bit.
Okay, okay, it's way up in the air. I do not like that at all. I prefer my board close to the bench, and that's primarily because I use the give me a long shot of me. Okay, you can't quite see it, but over here at the edge of the bench, I mean you're there. Okay, I like to rest my forearms, close to my elbow on the edge of the bench, and I actually have got the corner. Now you can go in overhead. I'll move in. Okay, I actually rest my palm on the table on the bench when I'm building. So what I did is I designed these little guys. I call them the brass set, and I can put them on a board like this, and they just mount very, very simply. Don't go running on my website, because after yesterday's thing, I'm really, really short on these babies, so I don't need any more over. And so now, see, I can turn this thing over, I can spin it around, and it's still it's as practically close as to the board as the bench as I can get, because I need room for certain parts, like things that stand up, like connectors and potentiometers and crystals and things like that. So, but that just basically allows you to move this board around and get in there and solder. So that's how I build it. So how many people we got? Should we start building this thing?
It's 21. People have been posting over on AirMeet that were over here. So
AirMeet's still not up, right?
AirMeet's still not up.
Okay.
It looked like it had let me in for a moment there, but then it wasn't.
I apologize. That's not our stuff. We're just agreed to do a workshop, and all of a sudden we can't even get in ourselves. Anyway, so we're gonna build this baby. Okay. So I'm gonna start. I'm gonna use these resistors. And according to my notes that I made earlier, one resistor is a hairpin. And that's the 100K. So I'm going to look in that resistor. I'm going to find that 100K. Brown, black, yellow, 100K. One thing you should do is, if you don't know your color code, you should have it on your bench somewhere on a card or something, because you get building kits. So I'm going to build it. I'm going to fold it over as a hairpin. And I'm going to put it, because that's a special one, I'm going to put that in first. So I'm going to put it in at the hairpin point, put my finger on the top, put it down the board, and I'm going to just bend the leads over a little bit like that so it won't fall out. And there's the first resistor. Now all the other resistors are all at 4/10 resistor spacing, which is typical. So I'm going to use a lead former. I'm just going to go and plunk it in, bend them over, and there you go, a perfectly bent resistor. I'm going to do all three of those. Okay, and I happen to know that the inductor is also 0.4 because it looks very similar to a resistor, so I'm going to bend that one too. So there you go. All four of those parts have been bent to 0.4 inch. 0.4 inch. So rather than go, you got two things. You can look at something. I'm going to put this 22 in and go find it, or you just pick one up, which is what I do. I pick one up and I see this is a 10, brown, black, black. That's a 10 ohm. So then I just look, and I happen to know that's part of the amplifier. So I go find the 10 ohms and I put it in, put it down on the bottom of the board, put my finger on it, put the leads spaced. So now that's held in there. Pick up another one. That's a 22 black, so 220. That's a 22 ohm. Put it at the 22 ohm. And bend it over. I got one left. I got the brown, black, orange. Now, I could just automatically go and put it in someplace thinking that it's the last resistor, so it's the last place it can go. But it's nice to check them. I see that's a 1K, a 10K, brown, black, orange. And I'm looking at the board, and I know the 10K goes up in here by the crystal. So there's 10K. Put that in. Okay. I'm going to hold it with my finger, spread the leads apart a little bit. Set that aside a minute because I'm going to also do this inductive, but first I got to cut. I got to cut the paper tape things off. Always put your finger on what you're cutting off, the excess, so you can hold it and control where it ends up so it's not in your eye or on the floor, in the carpet. And this inductor goes at L1, so I'll put it in L1. Push it down. Bend the leads apart a little bit. Okay, there we go. Now, I don't call, I mean, this is a relatively easy kit. There's not that many parts in it, so you could learn to solder with it, but I don't call this a learn to solder kit, primarily because if you look at the spacing, it's got integrated circuits, ICs. The pad spacing on them are very close. They're small pads close together. I wouldn't call that something I would want to put in front of a beginner solder because it's very easy to bridge those pins and not have a thing that works when you're done. So
how did you know to use the 0.4 on the lead former?
Because I designed it. And I know that 0.4 is the typical resistance spacing. Now that's why if someone doesn't tell you that, it's nice to carry a nice little scale in your kit, and this is at millimeters and inches, so I could have actually gone and just looked at that and measured it and I would know. But from 50 some years of building electronic kits, I can look at a spacing and I said, okay, that's 0.1 inch, there's 0.2 inch, there's 0.4 inch, there's 0.3 inch. Typical kits have those. If you're dealing in inches, they're usually 0.1, 0.2, 0.3, 0.4, 0.5. And indeed, your former has 0.1, 0.4, 0.5, 0.4 and a half, 0.5, 0.5 and a half, 0.6, 0.6 and a half. But you hardly ever get into this stuff unless you're using very big components. Like back in the old days when you had 5-watt resistors inside your transmitter, okay, you'd have to way down here. But most of the part, you're only using the very tip. And it just so happens I know that. I suppose I could start putting that on the thing, but pretty soon your bill of materials would be very, very complicated. But generally resistors are 0.4, inductors are 0.4, diodes sometimes are 0.3, but they could be 0.3 or 0.4. It depends on who laid it out. But you after a while you look at a spacing, you know exactly what it is. So now I've got 1, 2, 3, 4. I got 5 parts on there. I can start soldering. I'm going to take the iron. I use brass shavings, so I'm going to clean that tip on that iron. You can see it's nice and shiny. Get the dirt off. When I'm running portable, I keep my solder and I spool it off my 1-pound spool because here's a 1-pound spool. I don't always want to carry it with me. But when I do carry it with me, or carry a hunk of solder, you want to keep it clean. So I keep it in a plastic bag between applications or traveling. So I want to keep it clean. You want your iron clean, you want your solder clean, you want your board clean. So I'm going to put a little dollop of solder on the end. Now this is part learn to solder. And now I got that little bead on the end. I'm going to find that perfect spot to put it on both the pad and the lead. I'm gonna wait, a fraction of a second, add just a little dollop, and now when I see it wick, it wicks to the pad, wicks to the lead, got a nice little fillet there, it's done. And the thing is, you want to probably use 031 on typical. This is 031 solder. You can get skinnier, you can get fatter. 031 is pretty good for regular circuit boards. But if you try to use stuff that's too big, you end up feeding way more solder than you really need, and you get big blobs of it, and that's what you don't want. So again, I'll just feed just a tad, and it's a very small fillet. Now, because this is a very nice iron, clean tip, clean solder, I can do 3 or 4 without having to re-clean my iron. But so I might change that, clean that tip every 4 or 5 solder positions. But you can see that when I got this sea of lead sticking up here, it's so convenient to be able to just move that board around and find the perfect spot to get that iron tip in on that part. Now see, I can't get over here because I want to lay it right down the side of that lead and on the pad. And so I'm constantly moving my thing around. If you got one of those big gummy soldering things, as far as I'm concerned, that's like trying to solder with a 5-pound brick stuck to the board, and that annoys me. So, and you notice you're feeding very, very little solder to the pad afterwards, and that's primarily because there's not a lot of spacing around there. So if you get too much solder, it flows over, and you got a chance to bridge to something else or anything. It's just, you gotta learn that whole solder balance, and that only comes from practice. I've probably built thousands of boards over the 50 years of building. Now, using flush cutters, not side cutters, not dikes, flush cutters, because you can get right down on the edge of the board and lop that lead off. Yeah, there's stubble there, but it's as short as it can physically be. Later on, when you put this in an Altoids tin, you're gonna have a piece of cardboard or something. Then you have the board. Then you got a 9-volt battery in the lid. In certain cases, compactness is everything. So yeah, you need a good pair of flush cutters. Now, let me just one interjection tip. This is a pair of circuit board flush cutters. I do not use it to cut anything else. Oh, I thought I turned that phone off. I turned it off. I did. All right. Okay, I'm going to turn it off again. Power off.
It's not Eric trying to call us again.
No, I just double checked that. In the middle of our last one, Eric from QSO Today called it. She's
right.
Now I got it.
In the middle of when it was supposed to end.
Yeah, when we're about the ending point. Okay, so yeah, so I just made sure it wasn't him. So yeah, that fine point of just a little bit on the end of your iron to make the heat flow go to both the pad and the lead, and then just a little bit of feed. That's all you need. If you're just sitting there, cramming the solder to it, you're gonna have problems. But that's fairly clean up top side. And if you look, some of them may have been filled, some of them might not. But that's okay, because really that plated through hole, I know that I haven't too much solder, and that's better. I don't know if too little is better than too much, but I don't like too much. There's some sort of a good Marx Brothers joke in there somewhere, but I don't know. That's a too much. That's a too little. Okay, that's a just right. All right, so we've got the resistors and we got the inductor in there. Let's go for the capacitors. We'll go with the capacitors, because if you look at them, the actual tops of the capacitors, when they put down on the board, they're relatively close to the board too. But see, again, I don't have to worry about that with these guys. So I'm going to cut these off the strip with my pliers. Again, holding them so they don't go flying. I lost one yesterday. I had to go find it and replace it. Okay, so there's 3 of those. Now we got to determine what they were. So I got to read them. Now that particular part I can say reads 104, which happens to be a 0.1. I think I will very quickly go up on the thing and change that bill of materials document to include the actual markings. So I got 104s and I got 3 of them, and I happen to know that there's one right here next to the amplifier circuit, and I know there's another one up here. Where's that 104? 0.1's coming out of the either side of the mixer chip. So I'll put that there, put this one over here, this 0.1. So we got 3 of those in. Okay, they stay put. So we can throw that scrap away. What do we got here? We've got 2 more. Okay, 2 more 104s. We'll cut those off. Okay. The 104.1. There's one right there. Here's another 0.1. So where does that guy go? It's up top by the voltage regulator. So there should have been 5 of those 0.1s. Now I'm going to stop there, and I'm just going to. I've got a nice little sea of leads there. So, boy, I don't like that Weller. I'm sorry. That Weller drives me crazy.
You don't like my blinky light.
This thing is flashing about 10 flashes a second. No, it just went off. Okay, but yeah, I can see it over there out of the corner of my eye. It's flashing like crazy. Saying, "Hey, look at me! Look at me! Look at me!"
I'm usually looking at when I'm soldering, not the
Yeah, well, it's catching my eye though. That's what's bugging me because mine doesn't do that. So again, little dollop. Okay, so I can find that magic point and go in. Give it just a little bit of solder.
There you go. The Cartalk solution.
Yeah, if in doubt, throw some duct tape at it. Okay, but then again, I don't. Oh, I can still see it, but that's okay. But of course, on a solder station, that tells you that it's floating around the right temperature. When it goes off, it's the right temperature. When it comes back on, it's on the heat cycle. So that's just telling me that it's really finely tuned the heat cycle on that thing. There's not much of a band on it. So okay, so there we go. We'll get these guys over here. Any comments on, are these people building along with me?
No, pretty calm right at the moment.
Everybody's calm?
People are probably soldering away.
I haven't okay, well, I'm trying to do a lot of talking, so if anybody's got questions, interrupt us, because that helps maintain the flow so slower people can catch up. I don't want to go too fast, and I don't want to go too slow. I don't want to bore everybody to tears, but we don't want to be here all day.
That was yesterday.
Yeah, that was yesterday. We started
early,
at
ended late.
a little after 1, and we ended up at what, 3:30 or so?
We started here at like 11 just to make sure we were.
Well, yeah, but we went on live at like 20 past 1 or something like that.
Started noon.
Yeah, 20 past noon. I'm sorry. So again, I'm using lead, excess clipping control every single time, putting them in a nice clean pile. If you're building in a hotel room or something like that, they will be very, very thankful if you clean up that stuff and don't let it fall on the carpet. Okay, so I've got a few more capacitors here. Everybody with me?
Yeah,
Are you with me?
away.
Huh? Everybody soldering away? Okay, so I'm going to pick up another capacitor, and I see that's a 223, which happens to be a 0.022, which happens to be right here, 0.022, right at the bottom of the mixer. Now, here's the case where this is a 0.2 spacing on this capacitor, and the holes are 0.1. And you can elect to do something a little bit different. In my case, I'm going to take my needle nose pliers, and these are my favorite needle nose pliers. Square jaw, front, nice parallel things. It doesn't taper, so you can do square things with it. I can make square leads and stuff. So and it's got nice knurled things. So I'm going to actually bend these leads in like this. I'm going to bend that lead in like that. Now I'm being a little anal about this, because you could have just put it in there and shoved it down there, but I put it in there, and when I shove it down, it's going to look pretty much like a 0.1 space. It's going to sit nice and even, and you can see coming out I got 0.1 spacing leads, and so I'll just bend those to either side. And that's a case of, at the time, not being able to buy that capacitor with the right lead spacing. I try to match up the capacitor with the board, but a lot of times it's just not possible. You'll be in a wait cycle, especially for these through hole components now. They're getting harder and harder to get a hold of. If this was a surface mount kit, which probably most of you wouldn't want to be building, it might take, what do we do? Do we give 2 of those babies? I don't remember 2 being, yeah. Oh, this is I'm reading it here. This is a 221. The other one's a 223. This is a 221. So this is a 22 with 1 0, so 220, which goes right next to the local oscillator on the 6A SA612. Another case where it's a 0.1 spacing, but this is just a little bit different. So what I'm going to do is I'm going to take my pliers, I'm going to bend that lead out, then move in to where the lead was and move it back in. So I'm changing it from 0.2 spacing. This started off life as a 0.1 spaced capacitor, and it went through a forming machine and got turned into a 0.2. So I'm actually making it a 0.1 again. Again, you don't really have to, but it just makes it, on this tight little board, it makes it kind of interesting. So I can put that in there, and it fits in there very nicely. Spread the leads. And the one that was, let's see what this one here is. Three through four happens to be 0.33 microfarad, and I happen to know that's over here, and there's a 0.33 right after the switch. This is a 0.2 spacing. That's a 0.1 on the board, so I'm going to have to do my little magic again. I'm going to just take this and carefully bend it in, and I'm just going to bend it in a little bit, and I'll bend the other one in, and then if you look, I've made a 0.1 spacing out of a 0.2 capacitor, and so I can put that in, and it fits right in there nicely. Now, mind you, that's a lot of years of building kits and adjusting for parts. So I mean, I don't expect anybody to be able to do that out of the box, and I don't think you should expect to be able to do that either. But it's not that hard. And sometimes if you go to a ham fest or you see online a big bag of capacitors for $2, you get them, and then practice some of this stuff. This was the tough one for me, and I couldn't read it. The lettering on there is so small, I could not read it, and I couldn't read it with my magnifier, and I had to get out this pair of computer glasses and this pair of Coke bottles with my bifocals in them to be able to read that thing. And it says, oh, that's a 560. By the way, I'm wearing glasses. I have 2 pairs in my hands, and I'm using. This is a straight. This is my computer glasses, which are full screen, 28-inch reading glasses, and then these are my special with bifocals again. And I had to put them both together to be able to see. Oh, 560. I'm just verifying that we indeed kitted the right capacitor. And again, this is another one this is a 0.2 inch spacing, but you can see it start off as a 0.1. So to make it into a 0.1 to fit on the board better, I just bend it straight out like that, then go in right where it was, start it out, and bend it back. And now bend it out, go in, bend it in, and I have a 0.1 spacing capacitor. Pretty simple. So we put that in where 56 is. Now in this case, I'm having trouble with that thing, so I'm just take it off, makes all the room in the world. Put my fingers in there, set that thing down, get it in there.
Don't you have one of those optivisor things?
I have an optivisor that normally I would be doing that, but I don't wear that when I'm trying to do this because I wouldn't be able to see lots of other things. But optivisors are nice, and I'll tell you, I mean, I've bought them at Hamfest for $8 or $9 or $10, but I still have my good optivisors that I bought that were professional grade. They were like, at the time they were like $50, back when $50 really meant something. They've been broken. On a video I will do something because I actually have mine I fixed the whole joint mechanism because they had adjustable tension on them. They had 3 sets of these are not cheesy ones, these are real good ones. 3 sets of magnification. I didn't really use the 3 sets, but they broke right here, and I got a piece of circuit board that I crafted to put the whole thing back together again. And I've had them for probably 40 years. You buy something good, and something might happen to it, but when you fix it, you still have something good. It might not look all that great, but it's a great pair of visors, and much better, much more comfortable than any of the ones I bought at Hamfest. So I just cleaned my iron again. Whoops, I got a little bit of Durbers on one side, so I'm going to do it again. Nice clean tip, clean solder, little daub. And we'll go into the perfect spot for that one right there. Okay, and I'm going to move over to this guy right here. Again, not putting very much solder after the fact. Just a little bit. How are we doing people-wise? Any comments that we should be aware of?
Oh, that was the optivisor one. I snuck that one in on you.
You snuck that one in on me. Okay. Yeah, I use them.
It's officially 12:02, so our session is over.
Well, they're supposed at air meet. They're supposed to move us to a table in the front room or something. They're supposed to be on a side table. I don't know how in the hell all that stuff worked, but guess what?
Yeah.
Okay. Pay no attention to the man behind the curtain.
Feeling that air meet is a.
Yeah, there's definitely some glitches going on there. Okay, so there are those capacitors, and I'm going to clip those leads off. Nice and close to the board.
No longer look at air meet for questions.
Yeah. Well, sorry. We've done everything in our power to live within the air meet, but when the show doesn't go on, we find another way. That's the amateur radio code, isn't it? When the power goes out, we light up our portable operation.
So. It was just the Boy Scouts being prepared.
Yeah, so that all too. Both Steve and I are lifelong Boy Scouts, so you can see I'm wearing my flip to my image here.
Philmont Ranch hat.
My Philmont Ranch hat for the Boy Scout Ranch in New Mexico. I wanted to go there all my Boy Scout career as a kid, and I never got anywhere near close. I did manage to get to Pine Tree Camp.
I think I have my
okay.
My Boy Scouts wood badge shirt on.
Well, I finally got there a year ago. A friend of mine who was also a big scout. I visited him in Albuquerque, and we drove all the way up to Philmont and went to the store, and I bought some stuff. I bought this hat at Philmont, so that was as close as I got. It took me 50 years from after being a scout to get to Philmont. Okay, so we're doing pretty good. We're running out of parts to put on the board. I don't know what to choose next. I still got these big cans here. I'm gonna choose this little. Again, I'm looking for short stuff because I don't want to have to move my iron down in amongst all the tall things to get the short stuff. So I'm looking for things that are close to the surface of the board. So here's the adjustable cap, and I will put it in the 2 holes. Okay, spread the leads a little bit. What else can I put in? Here's the varactor diode. Now you can see it's got a shape to it, so I'm going to take that shape and match it up with the varactor diode shape that's on board. Now that will fall all the way to the bottom of the board, which I do not like, because if I ever have to yank it off, that makes it difficult. So I'm going to move it out by 1/4 of an inch, let's say, kind of hold it, and then bend the leads. Because when I turn it upside down, it's going to drop down, and it's going to have, there's about 1/4 of an inch there. I'm going to put this solder foot back on a little bit off to one side, so now I can hold it up there. So there's another. I'm going to put the voltage regulator in. So let's cut that thing off. Again, it's got a outline that you follow the outline that's on the board. You put it in. I'm going to hold it down by maybe not the full, I'm gonna somewhere, so that when I put it upside down, it's off the board by at least 1/8 of an inch. So the thing is, if I ever want to pull it off and replace it because I burned it up or something, if there's enough room, I can get my flush cutters in there and cut the leads individually. The body of the part goes away. Now you got 3 leads, and you can tackle each lead individually to do the removal, and it's much easier on the board when you do that. I can show you a trick on doing that. Okay, so again, I just clean my tip, add a little bit of dollop. Now I had a comment after yesterday's Learn to Solder from a guy, and he says, geez, that was a great workshop. And he says, and he discovered that he's been soldering all wrong for 50 years. Now, I'm not saying that my way is the right way. I mean, it's just the way I have made it through my career, and I found that it works pretty good for me. Now, it's not, some people might take exception to what I do in certain places. That's fine. I'm just giving you what I think is I found the best way of building something and making it come out right. He might not have been doing it wrong. He'd been doing it differently. That's all. Now, I like to make happy little resistors and happy little transistors. Anybody knows that reference? I'm going to put a happy little resistor over here. Okay, so
I was trying to get the color codes lined up.
Yeah. So okay, yes. Okay, Steve's telling me he wants all his color codes the same way. I don't care. I can read color codes forwards and backwards. I don't have to have them lined up in one way. So, hey, we're making good stride here. We've got a lot of stuff in there. Probably the next thing, I'm looking at the parts here. The next thing might be put on the 2 sockets. They're nice and close to the board, so I will pay attention to where the little divot is on the socket and where it is on the silk screen. So I can put that in there, hold it in with my finger. Nice to have fingernails too. See, I'm using my fingernail as a pick. And just bend those leads over so it stays put, doesn't fall off. Do the same thing with the second one. Goes up here. How are we doing? Anybody got any comments? Anybody telling me to slow down?
No. I got affirmation about lining the color codes out.
One person agrees with you, huh?
There's also compliments on holding your fingers over the leads so they don't fly everywhere. I also just put new carpet in here. I don't want to get the leaves
Yeah,
all over
Steve's
my
got
carpet.
brand new carpeting here. I build whenever I'm traveling. I'm always traveling with a kit. You know, I mean, I go to Hamfests and my hotel room ends up looking like my bench.
If you've ever taken a lead to the toe, you're
Yeah,
you're very clean
and
about where those
I am
go.
very conscious about leaving dribble behind on, you know, mixed in the carpeting. I do not like that at all. I don't expect to find foreign material. I got another story. I don't know. It's a funny story. Um, I used to have a company, and I designed electronic equipment for the disabled, and I built a combination talking box and an environmental control system for someone who is a quadriplegic, nonverbal, cerebral palsy, and had been in a mental institution for 16 years, his entire life. And I designed this box specifically for him because he was a patient of a friend of mine who was a speech pathologist. And within 6 months of him getting this box, he was placed outside the mental hospital. We called it Pineland Center, but it really was where they put people with cerebral palsy who they thought were stupid, dumb, but they weren't. He was smart as a whip. You know, he was everything. Things were going on in his head. He just couldn't tell people about it. I saw it immediately when I did an evaluation on him. So I built this box, and he got placed into a private home. Who also was a friend of mine. And that guy built him an apartment attached to his home. And he had another kid who had autism. So he had a two-person apartment. He was a fantastic fellow, my friend. And so he was independent. And he went home and saw his mother and his grandmother and all this kind of stuff. And this is after being in the institution for 16 years. So anyway, I was going down to show this box at an electronic aids for the disabled in Washington, D.C. And I asked my friend if he would like to come down on my dime and bring Hutch with him and have Hutch work my booth. Because I had made this game with RC trucks, and there was two trucks, and I had a track up there, and you had to tap the switch to be able to control your truck, and I had a switch attached to David's headrest, and then a customer could do it with whatever adapted switch they wanted, and it was a cool little game. And he was so excited, you know, his first time he'd ever been anywhere. And so we hopped in our van, and we drove down there. It was a long drive from Maine to Washington, D.C. And we got to the hotel where it was at the Hilton. It was a very quality show. So we had 2 rooms in the Hilton. And the first thing Charlie did was give Dave a bath because, you know, they had been in the van for a long time. So he gets in the tub. And you know, he's taking it, and you know, 2 minutes later, the water's all red, bloody red. And come to find out, someone in the guest in the room before them had broken the glass shelf over the toilet, and shards of glass have gotten in the bathtub, and no one found them, and no one had cleaned it thoroughly, and they had shredded David's butt to smithereens. And so we had to drag him out of the tub. He's on one of the beds upside down in the bed with his butt hanging out. We had the hotel manager, the hotel doctor. We had the ETs came in from the rescue squad, and there's all these people in the room. And Dave's spread out, and he's laughing. He's laughing his ass off is what he's doing because it is wicked funny. And so he gets patched up and everything is fine. And so the hotel manager, like, Dave, we're extremely sorry. And he comped him the room. He had baskets of fruit and vegetables and everything delivered to the room. So Dave was like, he was the most widely known person in the hotel. He really lived that up, and it was pretty damn funny. But anyway, so we set up the booth. We came back the next day. It was all set up. We went back the next day, and someone had stolen our RC trucks. all that way down there, and he never got to do his shtick. So, but he did get a free room and all kinds of free everything, free TV, free movies, free HBO, free food, free dinner. The whole thing was comp. So that was a pretty great. We talked about that for years. It was pretty cool. Okay, so now I'm going to 10 microfarad capacitor. So I see it's over here. The long lead is plus, the short lead is minus. There's a minus sign on the short lead. I'll put that in there. Whoops. Yeah, that's okay. I can do that. It's a little bit on the tall side, but we're left with not very many parts to choose from now. I'm going to put in the 220 first because I can see the 220 and the 10 down here are close together. So I'm going to put the big one in first. Okay, I'm going to set it down in there, and I'm going to actually solder these two. For some strange reason, I took off my things. I don't know why did I do that. I'll put them back on, but you can see I can go back quite easily. Oh, that's because that was one where the capacitor was. I haven't actually soldered that in yet. So I just put those four guys back on. I can set it down. Start to solder it. Everybody with us? So I'm going to go over and get that adjustable trim cap. Then I'm going to get the other. So a question came up yesterday about the solder. I'm old school. I still use rosin core. I use a name brand. I use Kester. I like Kester. I've been using it for 50 years. Why change? Some people have gone to silver solder. It takes a hotter iron. It's a little bit harder to deal with. The hotter the iron, when you put it to a pad, the faster you're gonna lift that pad if you've got excess heat. So I still prefer the low temp solder. Okay, so now I got those two caps in there, so now I can take the second 10, and you can see I'm gonna have to wedge it in here a little bit so I can see the plus and the minus, and it's gonna probably tilt off a little bit. Okay, but I'm gonna try to make it nice and neat. Now I'll solder that one in.
Did get a message from Eric.
Yeah.
Asking if I could go into the session and so that we could get things back on track.
Sure.
Yeah, I said I've been sitting in there waiting, so nothing's happened.
We tried. We waited to the last minute and beyond, but true to the ham spirit, it wasn't going to stop us. Okay, so we're getting there. Now we got a few other little things floating around. I'm going to install the two ICs next. This first one is the mixer 612. I'm going to sit it down, and I'm going to try to see these things are flared out when they're manufactured, and you'll never be able to get that into the socket. I guarantee you're going to inoculate yourself with like 4 of those pins. So I put it on a bench, and I just roll it. I'm holding on to all 4 of these pins with my finger. I just roll it so I basically square it up a little bit, the leads. Just takes a little bit, and then this thing is going to sit right down in that socket nice and neat. Okay, well, we're going to get a big call from the QSO guy. Finally, we texted, emailed, and everything this morning trying to get squared away, but it didn't happen. Okay, ICs are in. So we got a crystal, we got and a few connectors. So we're going to put the crystal. Oh, we got potentiometers too. So we got this is a 103, which is 10 plus 3 zeros. That's 10K. So we're going to put this over in the tune area. Get the leads nice and straight. Okay, so I'm going to seat it right down the board and bend the leads off. Now these could have been bigger pots and everything, but again, this is going in an Altoids tin, so you don't really have a lot of room to put a real live pot. I guess you could have drilled a hole in the side and put another smaller pot. A lot of people do that, but that takes hole drilling skills that a lot of people don't have. Equipment. So I opted to put trimmers on there because in a lot of cases you can trim it once. As the attenuate, I'm going to move this guy further towards the capacitor, which I've already soldered, so I can get in there and mount this baby right at the attenuation pot. And again, holding it down and moving, bending the pins with my fingernail. And this guy over here. Let me say something about soldering irons too. We went into that in great detail, but because this has ICs and very closely spaced pads, I'm using a very small conical tip on this. And the idea is I can go in there and just get on the pad without getting any additional area. And that just helps give you a nice good solder joint with not bridging to the next pad. And you want to, if you are into this hobby for the long haul, you want to get the very best soldering iron or soldering station that that you can part with the money. In my case, I use Zytronic and Weller, and I have a Metcal, which is like, the premium thing.
How do you know the SA612 pins are in the right holes?
Because it's got a little notch on the IC, and there's a notch on the socket, and there's a notch on the circuit board. So you build it so you pay attention to the orientation that's on the silk screen. Okay, so we now have the IC socket. Now the IC socket is this little guy, and there's no way it's going to stay in those holes for soldering. So what I do is I plug the crystal into it. Then I can plug it in there, and now I can use the crystal as a holder. So I'm holding it with one finger and I turn it over. Now the problem is I can't set the board down because the crystal's going to fall out. I got to feed solder there, and I got to get an iron. So I take and I use my little thing of solder. I put that up in the air like the Indian rope trick, and I just turn it down, a hook down. And then what I do is I put my little dab of solder on there, and I move that in there, and I use that to get everybody in sync. Come on. Okay, so I soldered that one pin. Didn't quite take. Come on. Okay, I got that one pin soldered. I turn it over and look at it and make sure everything's lined up pretty good, and it's the socket is straight up and down, which I think I need to add a little bit of. Okay, I think that's good. I'll check it again. I think it's nice and vertical. Set it down, and I'll do the other two pins. Clean my tip. Now, when those are cool, because that first one was kind of an iffy kind of a situation with the hands and things everywhere, I go back and I hit that at the very end. Now the other two are keeping it in play, and voila, it's in. So we've got everything on there except for the toroid and the connectors. So what we'll do is we'll tackle these connectors next. I got 4 of these 2-pin connectors. And again, the problem that you're going to have is that if you put a connector in and then turn the board over to solder it, it's going to fall out. If you try to hold on to it, if you touch one of those and you accidentally, if you're soldering on the other side and you're actually touching that same pin, you're going to burn yourself. So what I do is I take the connector, the shell part, and mate it up with the connector. Even though there's no terminals inside, I put it on the board, and then I hold that, and again use my pyramid of my tower of solder. I make sure that it looks flat and everything, and I'll do the same thing. I'll give my little dollop. I'll move in here. Okay. And solder one pin. I don't try to solder them all. I solder one pin. I turn it over and I look at it and I say that's nice and vertical. That's the connector's nice and flat. So I'll do the second one. Wait for it to cool, and then because that first one's a little bit on the dodgy side, I'll just do a little touch up. Add just a very little bit of solder, and voila, there's that connector, nice and soldered. So go after another one. Do the same thing. Put the shell on the connector. There's a couple little tabs over here, which is the lock that makes it only go in one way. So that helps actually keep the connector shell onto it. See, it's all one piece now. And I'll put that next to, I'll put that where the switch is. So put that in the switch location. Come on. Okay. Hold it down, bring my solder in. I'm going to have to make that hook a little bit longer because that's further in on the board, so I can make that hook in. Take my tip, add a little dollop, and shoot for that first connection. And there it is. Okay, I'll go make the second connection. Wait for it to cool. Now just redo the first one ever so slightly. It's cooled. I can take it off. I'll do the next one. Okay. Now there is an offset on these connectors, so it might fit better in one direction than the other based on how tight it is to other things around it. So that little leaning capacitor. Leaning tower capacitors making it a little bit more difficult, but I got it. Now that's on the other side of the board, so I'm gonna wrap my fingers a little bit slightly differently, and same thing, a little bit of solder. I'm gonna reach in there with that solder and put it right on the pad and thing, and add some heat. And, that one's not. Okay, there it is. Okay, so I can do the same thing. I'll get in there and get that second one nice.
How did you decide to make those blocks out of brass instead of steel or aluminum?
Do you really want to know?
I'm just curious. This is totally not a question from anybody out there. I was just like thinking, why brass?
It's a pun. It's a joke. You know, some in mixed company. I don't know if I should go into that, but
okay.
you know, and you got to get yourself.
Okay.
You know.
We'll leave it at that.
We'll leave it at that.
No,
some of you may know what we're talking about, and some of you may not. So, but yes.
Okay.
Well, there's another old saying about you got a lot of brass. You know, when you're being forceful in your whatever approach. Yeah, you got a lot of brass. Okay. Well, there's another phrase with brass set, but we won't go there. Okay, so there's the last connector. And you see they went in pretty easy. Once you know the technique of how to get that thing in there so that it's going to stay put and be able to feed solder to it. Okay. Now, because these are cheap nylon plastic, there's no real temperature stability there. So those are places you want to make sure that you get in and get out fast, because you can easily melt those pins right out of those connectors. So I'm going to go in and I'm going to shorten up all those pins. They shoot right up into your fingertip too. They're a little bit on the okay. So short of, we got a 9-volt battery snap over here. So the battery is here. We don't need tons of wire, but I'm gonna make sure that it allows a little bit of flexing. So I'm gonna go maybe about there. Cut the leads off. I never use the ends that they provided me at the factory, so I'm gonna strip those down. I'll leave that sitting up in the air a little bit, I guess. Make sure they're still twisted up a little bit, and I'll tin them again. These 9-volt battery snaps are the cheapest of wire, so you have to make sure you don't give it too much heat, or else you'll end up with a 1/4 inch of plastic being melted on the leads. So I'll put one in. Now, for the most part, that kind of stays put. I can bend it off to one side a little bit, and I'm off center for my soldering overhead camera. Take much, and I'll put the second lead in. Put the excess off. Okay, that's it, except for the only thing we don't have is we don't have the toroid in there. We gotta make the toroid, and we've got to make any connector shells, connector wiring. In the case of, where'd the little jumper go? Okay, we got the little jumper that on the switch thing. When you put that in, that makes the connection. So now the 9-volt battery powers into the circuit, and away you go. When you don't want it, you take it out, and you can actually go sideways with it and put it in. So now it's there, but it's not making the circuit. So we've got to use these connectors and make some wires. Now that all is a function of what you have for headphones or speaker, and because that's what the audio out here, and what you have for an antenna. I forgot to bring a long piece of wire. I was going to bring a long piece of wire and try to make a long wire antenna right here.
How long a piece of wire do you need?
I don't know, 10, 12 feet, something like that. Okay, I sent Steve off to get some wire. Meanwhile, the only thing we got left, we got these connectors, and we got to make our, we got an extra part here, okay, and we got this toroid. And the toroid is something you have to wind. A lot of people are scared silly about winding a toroid. Not really all that difficult. Okay. I'm going to do it right in front of you and without any aids, although it's a lot easier to do it when you got a tool. I'm not going to go there. Yeah, maybe I will. In a minute, I'll go there. So here's the red magnet wire, and we're going to need 10 turns of red magnet wire on that toroid. So I'm going to very carefully unspool it so that it's not kinked. I'm going to, what you call drawing a wire out, and I'm going to make sure it's nice and straight and no kinks in it. And then I'm going to go down through the toroid I'm going to leave an inch or two of wire there, and I'm going to hold it. I'm going to hold that with my bottom finger, and then I'm going to put my thumbnail where the wire comes out. And so now I can, just like threading a needle, I can come in, thread it, and then when I come down there, it's going to travel right along my fingernail until it gets tight to the body. I'm going to move my, what happened there? Okay, I'll try that again. I'm going to thread it. It follows right down my fingernail. So when I do that, I'm going to shift my fingernail over to cover that winding, and then do it again. So now we got 2 turns in there. So I'll go down. This is the third turn. I'm gonna bunch it up underneath my fingernail again. And you can see I got 3 turns there, pretty tight, nice tight to the thing. So I'm gonna put my thumbnail over it again. I'll go for turn number 4.
You're not using your little winder?
Well, I was gonna do that after I did all this. There's the winder. There's number 4. Okay, so I'll shift it over and collect it underneath my thumbnail again. Here's turn number 5. Some people are actually like this. Some people think this is nice and therapeutic, I guess. That was number 5, right? 1, 2, 3, 4, 5. Yeah, 5 turns. We're gonna go for number 6 now.
Eric didn't call while I was away, did he?
I didn't hear anything. Number 6.
Said send me your phone number. Yeah.
Number 7. Number 8. Number 9. And number 10. You got any comments about toroid winding? Anybody with me? Or anybody giving up now?
It's a dreamy kind of thing in there.
Okay.
Early afternoon nap.
Yeah. So there we go. We've got 10 turns, close wound on that toroid. So now I can cut that wire. About the same thing. And now there's lots of extra wire here, so you can actually do it once and say, I don't like that, and then do it again. I try to, actually when I do it, kids, I usually put twice the amount of wire that you need, so you can at least try it and not like it, not fail, and then still do it again. So I'm now moving the wires around the toroid so they're evenly spaced. I mean, it's not, you don't have to have it perfect. This actual design is so forgiving. All you gotta do is be in the ballpark, and it's gonna work. George actually made the comment about how did you come up with that circuit? He says, well, I remember the talk he gave. He says, you throw those parts up in the air when they land on the table. It's a good shot. It might land up in that situation. Okay, so there is my 10 turns of toroid. Kind of even. All right. Now, when I look at it, I'm going to go look at the board and see how the toroid is wound. The 10 turns go on the 10 turns are on the output. Bring up a schematic of that, would you?
I don't have a schematic. I don't have a bill of materials. The schematic's not on the site.
The schematic is not on the site?
No.
What's wrong with the guy?
That came up earlier, that the schematic was not on the site.
Really? Huh.
Yeah, there's a bill of material and the board.
Okay. Well, we can fix that real fast. Okay, go to this. Go to the receiver's logo or thumb. Go all the way to home.
Yeah.
Home. Oh, you on receivers? No, you're on billathons. Okay. Go to receivers. Why are you missing some of them? Okay, go to WWV.
WWVR.
Yeah, WWVR receiver. Okay, look at the schematic there. Okay. All right. What's the turns ratio on the isn't it 10 and 4?
Talking here, down here, L1.
Yeah, see look at where the antenna comes in, then there's a transformer. Okay. You see the
Yep,
winding?
3 to 10.
That's 3 to 10. Well, this one I think was 4 to 10. Okay, because that was set at 10 meters. This is now 20 meters. So now I've got my 10. I got my 10 meters like that. I'm looking at the 10 wants to be the 2 going. That's the output of this transformer. Okay, this is the antenna input transformer that goes off to the thing. It's the output. The 10 turns is on the 2 that go up to the trimmer cap. So I want that to be. So what I want to do is I want to take my green wire. Okay. I mean, I guess I should have a video just of winding this toroid. Okay, so take my green wire and I want to start. I want to start on this end. Same thing. I want to start on this end between the 2 coils. I'm going to wind it slightly different. I'm going to hold on to it and I'm going to come in.
What gauge is that?
This is, I think, 26 or 28 gauge. I need a little bit more wire. And I'm going to actually come in between. I'm coming between the red wires, red windings, and I want to make 4 windings. So there's 1, 2, 3. Can we see this okay? And I'm going to go for my 4th winding. And when I tighten it down, when I pull it and draw it through, I'm actually poking my finger. I'm guiding it so that when I pull it through, the wire nestles between the other two reds. So there it is. There's my 4 winding input side. Okay, so I can straighten them all out. All right, and fits pretty nice. So now I'm going to cut them all off. 1. Okay. Now, this is the trickiest part of the whole thing is now you've got, these are actually thermalese wires, so you can actually melt that covering off. I've said several times in this build that I'm an old school person. I don't trust that thermalese because that's a some sort of a plasticky kind of a thing. So what I like to do is I like to just basically take a razor knife and at 90 degrees scrape the windings, scrape that covering off. You don't want to have an angle because when you do that, you have a chance to dig and nick it, and you don't want to do that. If anything, you want to back drag it. If anybody's driven a bucket loader, or a snowplow, you want to back drag it because you don't want to nick. You want to dig what you've got. And I just scrape the solder off, scrape the coating off. So I'm on one side. Then I flip it over in my hand and I do the other side. Are we centered okay? All right. Mind you, it also is nice sometimes when you're doing this, you want to have a good sharp blade. So you don't want to use a knife that you've been doing all kinds of crazy things to, and it's got nicks in it, and the blade, you want a relatively clean blade. So it's nice to have a dedicated tool that goes in your kit building that only does things like this, so that the tool is good. So okay, I mean, it's not too bad. Now you don't have to scrape off a big long length. You just got to scrape it where you know that it's going to end up when you put it in the board. Okay, so I'm getting in between here and I'm just doing the sides just a little bit. Now some people say, oh, I'll put it in there and, let the iron melt that stuff off. And I don't know, I like to take a little extra time and I'm handling this toroid rather gently, because I don't want to screw up my windings. But any comments? Do we have any toroid winders out there? Monty, are you out there?
There's a little bit of a delay between us and when
Oh,
people can
okay.
respond, so.
Yeah. Okay, now I got most of this stuff off. Okay, so now when I go look at this, there are my 4 windings, and I can see that it goes in this way because I got my output, input, output, input, and the input is on one end of the coil. So there we go. So we just feed these guys in there. 1. We could have used a little bit more light on this. Looks like. Okay, I'm gonna put it upside down and do it from reverse, I guess. I guess that was. Okay, where am I? Those pliers. Gotta get this 4th wire into the hole. Okay, look at that. I got all 4 wires coming out the other side. I'll do the same thing. I'll bend them off on either end. Hold that toroid in place. It's sitting there standing up pretty good. Clean my iron. Get some solder. Now I'm going to actually go right to the wire first, heat it up, then go down to the pad. And that, in essence, whatever, since I scraped off maybe 90% of that stuff, the thermally insulation, I got a much better shot at having a really good connection on the board. So now in this case, you can smell that. You can smell that transformer smell, and that's the wire heating up. So I am going to take. I'm not going to cut them really flush at first. I'm going to cut them at like maybe 1/8 of an inch. Because I might have to. I'm going to test this board, test the circuit, and I might have to come back and reheat the wire. So it's nice to have a piece of wire that I can see that I can use as the heating point and not the pad. And there it is. We have built the kit, except we need some wire. We need something to go to the antenna, and we need something to go to our speaker. This little extra connector over here is if you want to go out to a frequency counter.
Put it down on the mat.
Oh, put it down on the mat. Okay. This one right here, I believe that said on the board frequency FC for frequency counter. And yeah, it's right next to it. You can see an FC. If you put a gimmick capacitor from over here where it says FC over to here, a piece of twist lead, and it's in the directions for like the WWV receiver.
P1 and P2 are green, and P1 and P2 are the green wire of the
primary is green, secondary is red.
So the primary is P1 and P2, and the secondary is S1 and S2.
Correct.
Yep.
And you want to keep, if you look at the schematic, you'll see the primary is it's not intersposed over the entire transformer. It's down on one end of the transformer. Okay. So the secondary is spread all the way around the toroid. The primary is just on what it was
And this
called.
is the WWVR.
That's on the WW. Yeah, I'll get that up there. Unfortunately, we've in my documentation helper has had a situation. I haven't been able to press him for any of that kind of stuff, so I will not do that. I'll see what I can get up in the next couple of days. But you can see this is the takeoff, a simplification to go in an Altoids tin of the sudden storm. So if you go on my website and look at the sudden storm receiver, which is same as sudden, and you compare the sudden storm to the WWVR, the WWV transmitter, the time transmitter out of Fort Collins, and the R stands for receiver. So that WWVR, that's another change from the sudden storm. Slightly better, and what we did is that's the first time we interjected an actual wound toroid into the input circuit of the antenna. So the evolution is sudden storm, WWVR, and then a combination of those two ends up being the mini sudden. So yeah, if you get schematics of both of those out, you'll see that, and I'll get the mods for the sudden, but the mini sudden. This is what you brought me for a piece of wire, huh? I got lamp cord, a big long thing of lamp cord. What is this for? Is this something good?
No. You want the other end that doesn't have the little thing on it?
Well, I was gonna say,
Doesn't matter.
can we rip it in half? Or would you prefer to keep it as lamp cord?
I don't know. Keep it as lamp cord.
Okay, we'll just try using one end. Give me the end that doesn't have these thingamajiggies on it. Okay.
I don't know where it came from. I don't know. I got two of them.
Well, of course.
You said wire. I just grabbed the first wire that I saw.
Yeah. Okay. All right. Well, it's my fault. I had it on my list of things to do is to bring some wire today so that we could actually make an antenna here. So.
It is technically wire.
Yeah, but it's awfully big wire. I mean, we got 18 gauge thing. There's no way I can put this little terminal connector on it. That's what I don't. Here's what I'm going to do. I'm going to take this, and I'm going to take this, and I'm going to cut most of these wires off. And now I've got just a few.
What are the two holes marked as A and R for?
As required. Again, when I design a kit, I always try to add extra features that, once you get to know it and you want to take it further, that AR allows you to again change the input impedance of the antenna signal going into the 612 Gilbert cell mixer. And there are all kinds of circuits out there that show all kinds of different variations. And the idea is if you have those holes there, then you can easily add a capacitor that adds extra capacitance to that input. A parallel capacitance to that tank circuit that is formed by this transformer and this trimmer capacitor. If, for instance, that trimmer capacitor needed more capacitance to get it onto a band that you wanted that's not 20 meters, then you can add a little parallel capacitor right there. There's pads for it. So this particular trimmer goes to 50 picofarad. And let's say, for instance, you look at a version of the sudden receiver, which is a very generic receiver. There's millions of versions of it out there, and you find some circuit that wants 220 picofarad input capacitance. Well, you've only got 50 coming out of that trimmer, so you can stick another 200 across those AR terminals, and now you got let's say you trim down to the minimum on the trimmer is like maybe 10, so you've got 210. You go all the way up and you got 250, so you can move that. So it's just a convenient place, just like this FC asterisk, and there's another one over on the other side of the board. Well, if you take a piece of ribbon cable from like computer ribbon cable and you strip it and then you twist it, I think it's 10 twists per inch, and you get about 1.5 inches goes from that point to that point. When you put that over there, that's about 47 picofarad. And now you can actually hook this terminal to the input of a frequency counter, and you got the correct line impedance to go into the frequency counter, and you should be able to read what the local oscillator is, if you need to know what the local oscillator is. So okay, here we go. I'm going to lay that baby in there. Since I don't have a tool for this, I just use my handy dandy, really nice pliers. I can go in there, because they got nice furls on them, I can go in there and get it at an angle and clamp that down. I'll do it 2 times. Okay, so now I've got that in there pretty good. Now I gotta hold this wire, because I got 20 feet of it laying off the counter over to the garage floor here, and I will. And again, this is the same kind of thing. You want to give it some solder, but you don't want to give it too much, because then it won't fit into the shell. So if I put that into the shell now, let's see, which way do I want it? Antennas on the. So you got an antenna and ground. In a lot of cases, okay, and that goes in here, so I want the antenna on the top side of this. So the hole's down there, so it wants to go. There. So now I can plug that in right there, and I've got myself a single wire antenna. I could take, because it probably wants to work against the ground, I could take any ground on the board and put it to a ground. I remember when we built the very first sudden storm receivers at a Dayton Build-a-thon, we didn't have an antenna in the room. So we took the antenna lead and we took a alligator clip and we clipped it to the cage of our soldering iron right there. So we had about, I don't know, 24 inches of wire, and we were turning on the sudden receivers and listening to hams in Ohio, Kentucky, West Virginia with 18 inches of wire. So it does work pretty good. So I got a minimum of stuff. I think we don't have a pair of headphones here on it either. So, and that was another thing on my list this morning. Guess what I forgot to bring over is a speaker, a small speaker.
Do you need an amplifier with a speaker, or just a speaker?
I can do either one. You got a little amplified speaker? Okay, we're struggling now to do the final steps, because that wasn't part of what I was really going after. But here's what I'm gonna be creative. I'm gonna take a 9-volt battery snap, and I am gonna wire it come on. What have we got? Anything? Oh, that's an awfully big speaker, man. No, I mean
I don't know if it's for
driving wise. How about any alligator clips? Do you have any alligator clips floating
You
around?
make me run back downstairs again, man.
I might be able to use it with this guy here. Okay, so I'm going after.
Tiring going up and down those stairs.
Yeah, those are steep steps out there too. Okay, so I'm going to tin this set of battery snaps, which I stole out of Steven's kit, his Learn to Solder kit from yesterday. So, we got any comments up there I should be talking about?
What's the name of those pliers?
You talking about my favorite pair of pliers?
Yeah, it'll take a bit before it's
Okay, all right. Well, you gotta be a little bit more. We got several sets of pliers out here, so. All right, so we're gonna take this guy. And we're gonna bend him in. That's why I like these blue pliers, man. I can get into really tight places, and because of those nice knurls on there, and very nice knurls on this pair of pliers, and I can bend these little teeny. Now I happen to have a set of terminal crimpers, but I'm not gonna actually crimp that. I'm not gonna crimp that one. I'm gonna throw some solder at it. I got the front half of that crimped. Okay, that's on there pretty good. Where's my other terminal? Let's see if I can crimp that baby just a little bit. You can crimp the first part of it and make it stay put. A lot easier to solder. Okay, that's on there. Okay, got that soldered. And I'll go back. Now that I've got the top half soldered, I can go back and just crimp around the insulation. And I say, what the heck is he doing putting that in there? Because what I'm going to do is I'm going to now I'm going to look at the connector, and I'm going to see the audio out. It doesn't really make much difference, but where does the signal come from? The signal goes on the top, and the bottom is the ground. So the signal goes on the top. So I'm going to put this like it's going to go in there. So the top is the signal. I'm going to make that red, keeping with nice code standards. Black. I see that one doesn't want to seat well because why? Because the top needs to be curled in just a little bit. Okay, now that's another reason why in my toolkit I have a nice little dental probe, because what I can do is I can entice that guy. Yep. I can entice that guy. Hopefully entice him and not that probe into my finger, but I can entice them right in there to snap. They have to snap into those things to lock. So both of them. Oops, see, that one's not snapped all the way completely in. So I gotta get that guy to go down there a little bit further.
What are the terminals and male headers for? I don't see where they are referenced on the circuit board.
Well, on
Terminals and male headers for.
the terminals go into these shells for making the connections that go out to antenna, frequency counter, and headphones or audio. The 3-pin header, that was a mistake. That we got carried away and we were putting those in to learn to solder. We got carried away and they accidentally got put in here.
And yes, it was your favorite pliers that they were asking about, the ones that you were.
Yeah, these blue ones. Yeah, they, I get those. I buy those at Jameco. I'll put a link on my webpage for those. Look at the Learn to Solder. Maybe I'll put that same link on this page too. But they're stainless steel. They got spring action, kind of nice. But the jaws are nice and straight. Beautiful knurls on them, a nice square nose, blunt nose. So I just love those things. I bet you I have 25 or 30 sets of small needle nose pliers, but I like these the best. Okay, so we've got this thing as built. We've got a connector for an antenna right here. We got a 9-volt battery spot, which I got a 9-volt battery. And so let's take this battery out, put it in the snap. Let's turn the thing on with my little jumper. Now we gotta get some audio. See if we got any audio here. I'm gonna put these. Look at this. How you like that? I don't know if you can hear that. I hear Morse code.
Here, I'm gonna turn up the gain so be quiet. Otherwise, it would blow them away.
Did anybody hear that? Can we get any comments back?
Well, we got one awesome.
Now, mind you, we have less than an idea. We got this big ass speaker here, which this little chip is not really meant to drive this speaker. Okay, you need something like a pair of headphones, which don't. I mean, there's activity going on here. Now, you notice that when I adjusted this cap, I don't have a real adjustment tool because okay, here we go. I'm using a steel screwdriver. Right there is where that's peak. Can anybody hear that?
Yep, they're hearing it. I don't know if I think they can still hear it.
Better antenna, pair of headphones, this thing performs. Okay. 9-volt battery. I mean, the antenna and the headphones are external. I mean, the antenna and the headphones. So this thing would tighten right up and battery would fit right in there. This fits in a pocket. Put it right in your pocket, shirt pocket. Throw out a piece of wire, put a set of headphones on, and you're on 20 meters listening. Now remember, you've got a tune signal over here too, so I can go over this pot. Jeez, I got multiple signals now. Uh-oh. I think I shorted the potentiometer. You see that pitch change? I'm changing the tuning of the local oscillator. Okay. But I hear at least 4 signals in there. And if we had a pair of headphones on there, so that you can turn the attenuation down. Okay, we're running like maximum here, trying to hear something out in this big. We're in a cavernous room over a 5-car garage. Okay, that tells you what we're working with here. And we got a piece of lamp cord that's maybe 15 feet long. So we're not working with ideal scenario, but this thing works. So with a decent throw-up antenna, I'm hearing multiple signals. I wish I had a better speaker. I've got this beautiful, I told you I had this beautiful little I don't even remember what it is now, but it's just a nice flat speaker. And I've taken it to several shows. I took it down to Albuquerque when we did the WWV, and I had everybody in that workshop wanted to buy that speaker off of me.
To buy the speaker.
No, it's my favorite speaker. But yeah, there it is. I mean, it's a nice little rig. The Sudden receiver is just a nice, very simple receiver that works. You can put it on multiple bands very simply. As you see, if you change that to 3 turns, I mean, actually, I think 4. Chuck Carpenter checked out the prototype of this, and he didn't change anything. He just changed the crystal, and he was on either 30 meters or 20 meters. If you went to 40 meters, you might have to change the inductor. Okay. I don't think you'd have to change the input circuit, even though it probably would perform better with a slightly different turns ratio. But be that as it may, I do believe it will work with changing the inductor. Now, instead of just soldering the inductor in, if you had 2 little socket pins there, then you can pop the inductor in and out and change it, and change the crystal in the inductor, and you're on a different band. Now, if you go look at my Sudden Storm, that's exactly what that does. You change the crystal and you change the inductor, and you're on a different band. That's all it takes.
So I asked if there were any last questions.
Yeah, come on, hit me with something.
People can hear it. Somebody supposed you might have left Magic Smoke out, but I think we avoided that.
No, well, it's working fine.
Magic Smoke still is in there.
The magic is still in this kit, that's for sure.
Nothing on the urban platform, so I'm going to go ahead and close that out, pretend it never existed.
We'll port this over to him for him. Yeah. Okay. So we're still here. We're in the feedback mode. Did anybody need any more help on building it? I mean, did they?
One fellow came in a little bit late.
Yeah.
And
mind you, we have lots of little text messages up here we have to feed through. So if you got something else, speak up again, because it's going to come to the top of the list.
James had come in a bit late, and earlier had said he was hoping to get the toroid winding, but I don't know if he got enough of it, or if the video was going to work for him.
Okay.
I'll wait and see. It'll take a second.
Our signals went away. I mean, we're still on the band, but they're kind of quiet right now.
Very cool. Got in late. Didn't see you went to YouTube. Built 99%, but need to do the toroid.
Okay. Now, I'm going to put a plug in here. I said I wasn't going to do it, but I will. Okay. Can I turn this off? So I'm going to pull my little... Now that's what they call motorboating, and I added a lot of extra impedance and capacitance in the circuit, and because the amplifier chip is being run at maximum output level, that by putting a little bit of unbalance in there, it will motorboat, and it'll come into self oscillation. That's typical, and sometimes you stop that just by changing turning the power on and off.
Did you say the pliers were DigiKey?
No, Jameco. And I say, if you go to my Learn to Solder, I'll put that document. I have a document maybe 75% done of the tools we used in the Learn to Solder workshop. And I introduced all these tools that I have, my preferred tools. And I'll put that document on both the Learn to Solder and the Mini Sudden. It'll go up probably sometime tonight or tomorrow. Really, we've been right out straight trying to get these workshops done. But it'll be up there in a matter of a day or two. So I'm going to show you something else. Okay, yeah. Okay. This is one of my toroid winding, easy winding tools. And what it does is it splits in half. And you put a toroid in the slot. You put it together. Come on. I make these in my shop by hand. Okay, so you put it in a holder. And you now have 2 hands free. Okay? So I'll go back to my red wire, and I want to do 10 turns. So I can just start there, thread it. I usually have my bench vise mounted right to the bench so it doesn't move or anything, and so you can see that I now have two hands. I don't have to worry about holding that toroid. I do the same thing with my my thumbnail. I get it in there to help draw the wire so it doesn't cross over when I'm drawing it tight. So I can put that right against the last winding, and I can move it over. Um, it takes a lot of the craziness out of trying to hold that toroid and manipulate the wire. But you can see that, gee, now how many turns have I got? I got 1, 2, 3, 4, 5, 6, 7, 10 turns. So I can take this now and I can spread the turns out like that. Okay, nice and spread out. So I'll go get my green wire. And I'm going to start at the same end that I started on the other side. So I'll start over here at the left. And remember that if you look at how the layout is on the board, the primary starts between the two secondary leads. So, and then when I bring it up, I make sure I'm between the leads again. I go back down. I make sure that it follows the red wire down. When it comes up, it's between the red wires. When it goes down, I'll do the same thing. Use my thumbnail to get it in there. And there is 1, 2, 1, 2, 3. There's my four windings, 4-turn winding. So I can take this apart. There's my toroid. It's going to install this way, that right there, and that's how it's going to mount on the circuit board, just like that. As you can see, that was rather painless. Toroids aren't that hard. You can do it by hand or you can do it with a tool. This is what I call my toroid easy tool. I sell those on my website under Homebrewing Supplies. You saw the benefit of the nice. Where'd the other 3 go? There they are. Circuit board holders. I call those brass set. That's a brass set. I mean, yeah, they're expensive. They're made out of brass, but then again, you can't. That's a brass set. You need to get one. Get yourself a brass set. I have several other tools floating around. I have a 6-way holder for putting boards together, circuit boards together when you make your own cases, and you can hold them at 90 degrees while you tack solder, all that kind of stuff. So yeah, if you go to the Homebrew Supplies, you'll see all kinds of nice boards and different things for doing that. So that's my plug. But that's what I do. I help guys build kits, and I help guys build kits from scratch. Any other questions out there?
That's the last one. James said thank you for redoing the toroid winding.
Just for him? Just for you?
Apparently just for him.
Oh, I was gonna show somebody. D it was. D, are you out there?
I didn't see a D earlier.
She was in the Learn to Solder yesterday. No D? All right, I'll send a video to you personally, but she put a header in upside down.
Yeah.
yesterday. So
Oh.
and she was afraid of using the solder sucker because you're going to goof it up. And I said, well, the header's upside down. All you got to do is use a sharp knife
Push the
and,
plastic
and push the
down.
plastic
Yeah,
up,
yeah.
cut the things off, and you now have a header with no plastic. The
Yep.
plastic really just holds all the pins together while you're handling it. But once it's soldered into the board, you don't need it anymore. Get rid of them. You're good. Cut her down.
Okay, I guess we're done.
Okay, I think we're done. What time is it now?
1:19.
1:19. So that was an hour and 19 minutes.
Yep.
Okay. Okay, well, thank you very much for coming over and seeing this whole thing. If you bought a kit, that's great, and I hope you got a pretty good heads up on how to build it. You see it does work pretty nice, and if you got a problem, you can reach back to me on my website, my email, tunicankits@gmail.com.
Okay.
Okay. All right. I'll get more documentation on both kits up on as it's being generated. Quite frankly, I had to slough off on the documentation somewhat to get the kits done, and I'll try to catch up on the documentation.
Looking for the model number for the pliers. Just said they'll be on the list.
They'll be on the list. Go to my, pay attention to the website in the next couple of days, and you'll see a document pop up about tools, and I'll have a nice breakdown of the pricing and the part numbers, where you get them. So I promised the people in the Learn to Solder workshop yesterday I would do that, and it's quite a bit done, but I just didn't finish it. So I'll get it up there in a day or two.
See you all next time.
Okay, all right. Stay tuned to the QRPME website because I'll do some more of this stuff on a occasional basis, and I'm interested in popping up more YouTubes on my kits because people like the way the YouTubes sort of clarify what they're looking at. So